Okay,
minus secant squared over pi.
and
Plus square root of 2 secant pi over 4. I mean, cosecant, sorry.
cosecant,
Yes.
5/4.
Yes.
Okay, got that. Guys, this is one that's missed most often. Now, though, with the discussion we had tonight, it might make more sense. That pi/15, I agree with you, this is an angle you have never seen, not pi/4, pi/3, pi/15. This, those two have a connection. It's this connection. It's an identity.
Yeah, that's
Now, if I would sort of take that identity and manipulate it, modify it, and make it work here, then this says tan squared minus secant squared. Guys, if I move secant squared over here, that becomes tan squared minus secant squared. If I move the 1 over here, I'm just modifying the identity. I can write this as conclusion is tan squared, secant squared is being moved over in the identity, and the 1's being moved over to the other side.
Yeah.
That's another way to think of the identity. So all that's blocked off is merely this. No matter what the angle is, as long as it's the same angle, pi/15, pi/4, pi/12, whatever it is, it's always -1. That's what the identity says. Now in the end, most students have this correct. Radical 2, and guys, I think when you finally think about cosecant 1 over sine of 1 over y for pi/4, it came out to be another radical 2, I think. And you finally end up with, Marco, -1 plus 2, so the answer was 1. Put that one on the exam. Did I have some students? I am pleased to announce, that's why I was telling my colleagues. I said, are you kidding? I didn't think anyone, and all of a sudden I start scoring, and that's why it takes me so long to score papers, because I'm looking at every little mark you make. I had some students doing this. They were doing this to get the answers. Absolutely, so it worked out. Makes sense now? With the help of one of the identities. Okay, absolutely. Now, Sarah, I think 6.2, I had just a couple problems with a U in it. The reason I threw that in, I'm going to do one of them. Okay, let's call this part 1. We're going to finish this handout up. Feeling better about the chapter 6 now. Okay, part 1. Sarah, please read to me. It says find the exact value, I think. Does it? Over in the direction, or express or something. How was it?
Given, write the given.
Okay, right. The given expression?
The given trigonometric.
Trigonometric? Okay, I'll just call it given expression.
Yeah, as an algebraic expression.
Okay, as an algebraic, we'll take that as what?
Expression in U.
As an expression.
An algebraic expression in U.
There you go. Guys, I skipped a few words, but this is what it comes down to. So she's going to give me the expression on your handout, and they want you to rewrite it. And then we're in terms of U. Now, what was given?
Sine, parentheses, cosine, inverse.
Sine of inverse cosine of U.
Yeah.
That's what they're asking me to find.
Yeah.
Okay. Now, David, after that beautiful lesson your professor did before the break, I usually place the number like, here like 1/2, radical 3 over 2, 0. We think about what's going on here. Here they said, no, let's just open it up and call it U. But I don't know what U is it positive or negative? So we're going to do this. I know altogether this says, translated, there's an angle out there that when you take its cosine, you get U. Now, at this point, I cannot identify which quadrant am I located, because I don't know what U is, so I'm going to just leave it like that. They want sine of that. Now, is there an identity out there that has a relationship relationship between sine that I'm looking for and cosine, which I have on the board in red. Samantha,
Sine squared plus cosine.
let's
squared.
use it. So this is first, number two, she says, now, Professor, incorporate this. And when I'm gonna incorporate, I'm gonna replace cosine with u, which it is. It's a little strange, that's what it says. If I want to solve for sine, I got sine theta. Let's move that u squared over. Now when I take a square root, sine squared, when I take a square root, I'm gonna end up with sine theta is equal to, really if this one's plus minus, because I don't know where I am, of 1 minus u squared. That's true? Now, I know it's tempting. We're finished. They asked me to find sine. Right there it is. I found it. Best I can. Plus minus square root 1 minus u squared. Now, what's tempting for students to say at this point, which you cannot say? That's, oh, it's so tempting to go one step further. What's so tempting to do here that you can't?
Oh, I know.
Looks like square root 1 minus u squared might be a perfect square root. Like
Like you.
1 minus u. It's not. You gotta stop here. That is not a perfect square root. You gotta leave it like you see it. Then I'm finished. It's a problem. Okay, I will ask you 5. Now, I'm not gonna do the next one. Do the next one have a tangent in it, which can be done something like this, but you do a sine or a cosine. Okay, so here it is in terms of u. That math 7, math 8 class will probably express a lot of the work in terms of another variable, something like a u. So I thought I'd bring that in. Now, Sarah, tell me what on earth is section 6.3? That's solving equations?
Yeah.
Okay, hang on. Gotta get this done tonight. Solving equations. Can you tell me what equation did I ask on the handout to solve first?
Cosine theta equals 1/2.
Cosine theta is equal to 1/2. Sarah, did I have on the side any restriction as to where that angle is located? No. So they're saying find all of them. I mean, all of them. Now, surely because on that handout on the unit circle, you have seen a spot there, maybe 2 places,
Yeah.
where cosine, the x coordinate is 1/2. Can anyone think in terms of where is x coordinate 1/2 or cosine 1/2?
Pi
5
over 3.
or 3, I'll take that note, it's in quadrant 1, and I think there's another one.
Pi over 3. I was about to sit down because this. Pi over 3.
I think it's 5 pi over 3. Is it 5 pi over 3?
Yeah.
You're different things here.
4, yeah.
That's quadrant 1, quadrant 4. That's where cosine is positive. I have to accept both. Now, Marco, that's why I asked Sarah. They said you solve. I'm supposed to solve all. Find all angles, not just the 2 you see staring at me right now. So can someone be clever in this lesson and tell me, how would I tell someone that not only does pi over 3 work, let me name another one for you that does work. Let me see if I can think it real quickly. 7 pi over 3 also works.
Yeah.
I can name all evening angles that will work here. We're so accustomed to stopping at 2 pi. 1 revolution of that circle. No, here they want all. Now, can anyone give me a suggestion on how can I show someone there's more than just pi over 3, there's others. And there's more than this one, there's others. That'd be clever. Sarah?
Well, you could say pi over 3, and then also, like, just for pi over 3, you could say pi over 3 plus 2 pi k.
Oh, hang on, she says, Professor, don't stop there. This would repeat with the period number, which is 2 pi for cosine, any number of times you wish. 2 pi k, as long as you make that k an element of the integers. I can do the same thing at 5 pi over 3. If I want more, repeat the period, 2 pi, any number of times, k, where k is an element of the integers. And those are my solutions. That picks up every angle out there I don't care how many you list, you list them all day. There's an infinite number of answers, and they must satisfy one of those two. And it will work. Yes?
Integers also count negative numbers.
Yeah, negative numbers.
Oh.
You got negative, positive, zero, absolutely. So guys, this is done, we're finished. And your textbook calls this, in a case like this, where they have so many answers here, they call this a general solution. I have a general solution. You'll pick up all of them. Before I leave it, we're done with it though. Aiden, let me ask you real quickly. If I should replace k by 10, that's an integer, this becomes 20 pi. If I take 20 pi plus pi over 3, I'm trying to put together with a common denominator of 3. Guys, help me out. 20 pi plus pi over 3, put together like fractions with a common denominator of 3. Is it 61 pi over 3?
Yeah.
Guarantee you, you put it back up here, it'll satisfy this blue. It'll satisfy the equation. So you can list these all day, so it's called a general solution. Now I think some of these though on the side, I put a restriction.
Yeah.
Okay, tell me what letter B says.
Cosine of cosine 2 theta.
2 theta,
Yeah. Equals 1/2.
1/2. Now did I place a restriction?
Yeah, it's 0 is less than or equal to theta less than 2 pi.
Beautiful. I think your textbook uses this for some time. Now, I cannot write a general solution. I'll come up with specific numbers that are called between 0 and 2 pi. First, guys, to solve it, give me some thought before I show you what to do. Got cosine 2 theta is equal to 1/2, trying to solve for theta.
Do we need to
Lisa,
divide-
talk
do
to
we
me.
need to divide it by 2?
Nope, I knew you were gonna say that's why I put the, want some response here, that's why I threw that question out. You cannot divide by 2, the 2 would have to be out front. If you divide by 2, that's the most common answer I hear, that's why I asked that question. No, can't divide by 2. Now we're stuck.
Find the restrictions?
Nope. No solution. Oh, there's a solution. Now, let me start you out. That's all I think I did a while. Guys, to treat this,
Just like radio.
now, hang on. We have to treat this and this. That says, if this were missing, it's not 2 theta, it's just an angle there. It says, where have you seen cosine equal to a 1/2? First, let's get that out of the way. Where have you seen on the unit circle cosine equal to a 1/2? Pi over 3, was it? Pi over 3. And I think another spot is, is it 5 pi over 3? 4 probably. Now, what you're gonna do is say, hold on, Professor. That means this end here is representing either pi over 3, 2 theta, that's representing pi over 3, or it's representing 5 pi over 3. Translation, it says 2 theta is representing this for it to work. And by the way, I'm going to add to this at this point 2 pi k if I want things to repeat at this point. And the period number for cosine is 2 pi. This one, I'll put it out here, that 2 theta must be representing 5 pi over 3 if I expect this thing to work. Or it could be another angle out there somewhere, 2 pi k, where k is an element of the integers. We know what that's going to do. That's where we set it up. That 2 theta must be representing either pi over 3 or 5 pi over 3. And I put the 2 pi period number to make things repeat. Find all of them right now, even though they're saying just find here. Guys, now I've got to solve for theta. I'm running out of board space here. Now to solve for theta, Lisa. Now I will divide by 2. So I'll divide by 2 here. Everything. 2's cancel. So theta's equal to, guys, we'll end up with pi over 6. 2's cancel on the end, leaves me pi k. Where k is still an element of the integers. Now that is a general solution. And over here, divide by 2. We'll end up with 5 pi over 6. quickly, plus pi k, where k is an element of the integers. There's another solution. Now, that's great. That's all of them, all infinite number of answers. Now, Sarah's telling me, Professor, all they wanted was those that are caught between 0 and 2 pi. So what am I going to do? I'm going to take the one at the bottom there, which says this. Watch, careful what I'm going to do here. And do this. I'm going to start letting k be some integers. Now, I think Marco just mentioned, could I let k be a negative? I could, but they said make sure the answers eventually fall between 0 and 2 pi. So I don't want a negative answer. So I'm going to start with 0. We'll let k be 0. If I let k be 0, guys, this term here drops out. Leaves me for an answer 5 or 6. Now I said replace k by another integer, 1. If I let k be 1, here we go. Theta in this case will be pi over 6 plus pi, common denominator 6, 7 pi over 6. Oh, by the way, 7 pi over 6, will that fit between 0 and 2 pi? It does.
Yeah.
Now if I try another, maybe I can find another one here. Let k be 2. Sometimes you can. Theta in this case will be equal to pi over 6 plus 2 pi. So I go ahead and put them together. I'm end up with a common denominator of 6. Guys, I think that's 13 pi over 6. Now, that is beyond this one.
Yeah.
They said stop at 2 pi. So this one will work, but it's not in that interval they gave me for a restriction. So even after all that thought there, even though the last one works, at this point I have for an answer, down here, all places in the set, I got 7 pi over 6 and pi over 6. I have pi over 6 there first. I have those two at this point for solutions. This one works, but darn it, 13 pi over 6 goes beyond this, 2 pi. So I can't use it, even though it works. Now what must I do? I must do the same thing on my second solution. My second solution, guys, is down here. Let me bring a view in case you guys can't see it. My second one says theta is equal to, here goes, 5 pi over 6. Yeah, plus 5%, plus pi k, where k is an element of the integers. Now, same thing, let k be 0, let k be 1, and this is as many answers as you can. If I let k be 0 here, that term drops out, and I'm left with 5 pi over 6, which is 150 degrees. Will that fit between 0 and 2 pi, like they want? So I'll take it. I'm going to let k be 1 next. That's an integer. Maybe it'll work. Guys, going to let k be 1 up there. That is now 5 pi over 6 plus pi. I think it's 11 pi over 6. And I'm trying to convert that to degrees right quick. I think it's 330. Will that fit?
Yeah.
I'm good. Looks like it's awfully close though. Let's go out to 360. So this one's 330. I'm going to try it for you. If you let k be 2, it'll go outside the bounds there. Wow. So what are my final answers? I've got 2 listed already. I just now picked up 2 more. There's one here, add to the group. I don't care what order you place these guys. 5 pi over 6, 11 pi over 6. Close this up. And those are my answers. And they're all caught between 0 and 2 pi, or 0 and 360. What's the matter?
If you didn't give us that restriction, would the answer just be the general solution?
Thank you. Absolutely. If this was lifted, where am I? Missing. They did not place a restriction on me as to where the answer should be. She's exactly right. You would leave these answers easier. General solutions. Leave it like that. Does that make sense, guys? Everything put together? Now, the next one?
2 sine squared.
And that will get something you like. Let us see, 2 sine squared,
2 sine squared theta minus 3 sine
okay,
theta
okay,
plus 1 equals 0 with restriction of bracket 0 to pi.
we got a restriction on this one. This one's gonna be nice. This one's gonna be nice. What do you think this reminds you of? I know it's a quadratic. What do you remind you of? That we've done so many times in this class. Students have done it in this class. What does this remind you of that we've done so many times to make this work out? There.
Let u be sine.
It is. Let u be something and rewrite it and have a quadratic and take us back down to a quadratic here. So let u, Sarah, since you gave that to me, what would you let u be in this case?
Let u be sine theta.
Sine theta. Therefore, I can now rewrite this, which looks impossible, but now it looks like this. 2u squared minus 3u plus 1 is equal to 0. Now those kids across the street can do that. I think of factors, or you use quadratic formula. We'll go ahead and factor. Split this up real quickly, guys. We'll end up with u to be a 1/2 and u to be a 1. She says, no, Professor, u is representing sine theta. So it says sine theta is equal to 1/2. Sine theta is equal to 1. Now all you have to do is go to that unit circle and tell me where have you seen the y coordinate sine equal to a 1/2 to begin with. Get me started. Is it 5 or 6? Is that one spot?
Mm-hmm.
Is there another spot on the circle where you've seen the y coordinate 1/2? 5, 5 or 6. By the way, as I list these, they do fall between these two. And over here it says, now where have you seen sine, the y coordinate equal to a 1? 5 or 2. And you are finished. This one's a little bit easier. So I got 3 solutions. Like I said, I don't care what order, 5 or 6, we can put 5 or 2 next. And then 5, 5 or 6. Deliver the answers. So you solve the trig equation. Sarah, how many more of these are there?
There's 3 more.
Okay, tell me what the next one looks like.
Tan theta divided by 2.
Oh, hang on. Tan of theta divided by 2.
Yeah. Equals that over 3.
Whoa.
With the restriction of parentheses 0 to 3 pi over 2.
Whoa, whoa, whoa. Look like this.
Yeah.
Welcome. Welcome to math. Guys, if you go from 0 to 3 pi over 2, they're giving me what quadrants? Oh my goodness. Are they saying find the answers?
1, 2, 3.
Looks like, what, thank you, looks like quadrant 1, 2, 3. You said you just give me 2. Now, find this. Where on the unit circle first have you seen tan equal to a radical 3 as your little reference to begin with? Okay, if that's true, then that theta over 2 that she gave me is representing pi over 3. And I'm gonna put the period number here in case I need it, plus pi k, where k is an element of the integers. Anyone tell me why I did not put 2 pi k? I've been using 2 pi.
That's the period.
It's the period number for tangent pi. If you look back to your tan graph, the period there was tan, for tan was pi. Solve this for theta, guys, multiply by 2. Gotta be careful. Multiplication by 2 will give me this. What we have worked hard part tonight, plus this, where K is an element of the integers. You guys aren't the top scoring group in your math 7, there's something wrong. After all this work. Okay, multiply through by 2, I hope I did that correctly, looks good. And that is a solution. Now the problem is, oh boy,
What should do to?
is there another one in red there besides pi over 3 on the unit circle where y where x tangent gives you a radical 3 again? Lisa? 2 pi over 3.
No, I'm saying 4
No,
pi.
hang on, just what you said. You said 2 pi over 3, that's what you said.
No, it's.
Okay, no, it's not gonna work. What's tangent in quadrant 2? Negative. You're saying too much. Now find another one.
No, that, you said we need the other.
Now I just want the other angle.
4 pi over 3.
Out here now, the other possibility is theta over 2 could be, I think you said what, 4 pi over 3, was it?
That's what they said.
4 pi, I thought you said 2 pi over 3.
No, it's 4.
Yeah, it's 4 pi over 3.
Yeah.
Plus 2 pi, oh, pi k, where k is an element of the integers. Is that true, guys? If I have the right angles. Now if I multiply this one by 2, we're going to end up with this. 8 pi over 3, and that changes out to 2 pi k. And now all I need to do is try to come up with, here we go. That's another general solution. And I think you guys have, from what to what, from 0 to 3 pi over 2, that's quite much
Yeah,
to cover.
yeah.
Guys, if I go back in, let k be 0, that's an integer. We'll start out with, Professor, can I use 2 pi over 3? Well, that's 120 degrees, and that would definitely fall between 0 and 270. If I let k be 1, I'm going to end up with 2 pi over 3, so let's replace k by 1. I'm doing math in my head here. Is that 8 pi over 3? Do it real quickly. K is 1, you put these together with the common denominator of 3. Is that 8 pi over 3? So let me check, see if it's right.
Yeah.
Now, I'm trying to think, with 8 pi over 3, this is going to fall between these two. Does 8 pi over 3 fall? And it may be difficult for you to see if it does. You could, since that's a 3 and that's a 2, you could replace this restriction with, we'll change it to a 6. 9 pi over 6. And this is really 16 pi over 6, if you want to get a comparison. Is this one outside? You know it works, I can use it. So right now we have one answer. It was 8 pi, 2 pi over 3. This one works, but it's going to reject it. Wow. Now if I do the same thing here, I see right now on this one, if I replace k by 0, does that give me 8 pi over 3 again? Strange problem, but here we go. 8 pi over 3. Now guys, I think if I replace k by 1, I think that's going to take me outside the interval they gave me. You guys agree or not? If I replace k by 1 and do the math, so that's going to take me outside this.
Yeah.
I think it's going to. So it looks like after all that work, are you kidding? Looks like I got what, 2 pi over 3, and what was the other one? 8 pi over 3? To work? Yes, no? I think. Okay, so here we go. 2 pi over 3, 8 pi over 3. Strange numbers, but looks like it might be that. Wow. Now, David, I have not been checking these. You see how much work it's taken just to solve these. This one, this one over. I'm gonna say, hold on now. Sometimes you get strange answers here. I don't know, Professor. Could you show me a quick check and see if those answers are correct? Let's take 2 pi over 3. It says the tangent of, now I'm replacing theta by 2 pi over 3, which is over two. And we're supposed to get this if it checks. Let's place a theta right there. Clean this up, looks like it's gonna be tan of, what did this simplify into, guys? 2 pi over 3 over 2. You wanna see what that might simplify into? 5 over 3. Now please tell me tan y over x at pi over 3. And pi over 3 has for coordinates, help me out here, 1/2 square root 3 over 2. Replacing y over x, will you end up with radical 3? I think you do. Yeah, guys, I'll get that. You got it?
Yeah, I got it.
You got it? Yeah. So this is, check, it does check. And 8 pi over 3, to save you a little time, but you could go through, plug it in, just like you check an equation, and it should check. Woo, I hope it checks. Now, Sarah, I'm looking at my time here, because I want to finish this up. I want to finish this worksheet up.
Okay.
You tell me, I probably have 2 more to do. Okay, I'm gonna do 1 more. I think we see the routine here, so we'll take a little practice. Tell me what the next one looks like, and I'll go see what, the next one's
Secant 3 theta over 2 equals -2.
like. Okay, and what's the last one?
Oh, 1 plus sine equals 2 cosine squared.
I need that one.
Okay.
Okay, letter E, here we go. Sarah, read that to me one more time.
1 plus sine theta equals 2 cosine squared theta with a restriction of bracket 0 to 2 pi.
Now, this one, I think might be a little easier. Now, as I look at it, looks like it might be one of those, eventually where I'll let you be something. But, it looks like they gave me a sine with a cosine squared. Now, what on earth, when I placed this on the handout, was I reaching for, looking for, on this? Well, I place this as the last one, what am I trying to get my students to do here to finally get this thing in a good form here so I can finish it up? Something else that ties in with something we're doing before the break. That's why I brought it in. Can someone see what on earth being clever that I might want to do here to make this work? Now, if I ask you to let you be something right now, I don't think you need to know what you was. So if I want to finally let you be something, like I let you be something in an earlier problem, I don't know what you is. So maybe I need to modify this a little bit and use something we saw before the break to do that. Does anyone have an idea of what on earth am I looking for here? Marco, give me an idea.
Would you subtract the 2 cosine?
I could, but I don't need, I could, but I do not need to right now. Something more important. To begin. I could divide by 2, absolutely not quite yet. Something we're overlooking, and we have done so many before the break, that's gotta be used here. What on earth am I looking for? Why would I bring this in?
Tolerance?
What else? Yeah. 1 plus 1 is equal to 2, so bring that in. Now,
Do we need a comment, like, not a
yeah, you got sign, just like me going across the street to the kids and they say, solve this. You say, what do you solve? I want you to solve this. That's what it looks like. 2 variables. These kids across the street aren't gonna be able to work with 2 variables. They're gonna work with 1 variable. This thing has 2 variables. So what on earth would I bring, why would I bring this in that section there? What is it that we need to do here first, and then it'll work out?
Find the inverse?
Tell me again.
Find the inverse?
Not the inverse yet. Something else I gotta do before I get to the inverse method.
Well, can't you use like identities to find a common?
We gotta use an identity. I want this in common of just side, just a sine all the way across, or cosine all the way across. It's mixed right now. Got an X and a Y. So here, Samantha, with your help, I can quickly say, hold on, Professor, I know this identity. And I could go ahead and solve for cosine squared easily in that identity. Move the sine squared over, if it will help. And now I got a replacement for cosine squared. I can put it in there. Oh, by the way, does that replacement for cosine squared have a sign in it? And now if I do that and rewrite my equation, here goes. This now, guys, becomes, left-hand side stays like it is, no problem. Now it says 2 times, and with Samantha's help, in place of cosine squared, you're going to put this. You're going to make a substitution. Now, thank goodness, everything's in terms of sign. You guys see that? Now, if I clean this up, and I mean, be careful here, not mess it up. I got 1 plus sign, distributive property, no problem. And to make this look like, and it's going to be a quadratic. Let's move things around, guys, make it look good as a quadratic. Let's put that 2 sine squared first on the other side, moving things around. Plus sine. And finally on the end, I got 1 minus 2, watch out, I'm not gonna let me mess up here. I think it comes out to be that, when you start moving things around. You step back and look at it, I think it is. I think. Now can I let u be something?
Yes.
Jeez. Yeah, I'll let u be sine theta. And finally finish this equation up. It's work out here. I can let u be sine theta. If I do, this becomes 2u squared plus u minus 1. That looks so much like one I just did earlier. Factors, 2u, u, plus 1 down here and minus 1 here. I'm doing it quickly. Split this up, you're looking at u to be a 1/2. U is equal to a negative 1. Wow. Now, Sarah, can you tell me now what might you suggest I do at this point? We're not quite finished.
Sine theta.
There you go.
equals
U was representing what was it? Sine theta? Back here somewhere. Right here in front of me. Sine theta is equal to 1/2. And then also I have to say what? Sine theta is equal to negative 1. Wow, that was good problem in the section width. Now, thank goodness this one takes me back to the unit circle. Sine is 1/2 at 5/6, and also 5/6. Sine is equal to negative 1 on one place, 3/2. I'm hoping those 3 fall between, as she gave me, 0 and 360. I think you all do. Okay, now I'm gonna list them for you. You see them on the board here, already done. They came out to be 5/6, 5/6, I'll put it in that order. And finally 3/2. Close that up. You got your answers. I don't want to see anyone here in winter. My winter class is full. Canvas will tell me shortly. After that final exam is given, Canvas will tell me. Do we have to repeat winter? Or they want to wait till spring? I don't want that to happen to any student who's worked too hard. I mean, everyone in this class has worked too hard. Do not let that happen. Don't let it happen to get a D. Expect to see or better from everyone. I've worked hard, Parks worked hard, and we've all worked hard. Don't let anything drop below C, and I'll be happy. Now, I see my time here, but You know me. I do see there's one more little part of that handout that I had not got to section, what was it? 6.4, 6.4. So that, chapter 6 is almost done. Almost done. If I were a student, and one thing I will applaud for you guys, commend you on, when I scored that last test, and when I'm in class, I'm discussing it, I receive input from students. On this last test, you wouldn't believe the number of students who wrote out so organized. Everything's just organized for me, where it takes me as an instructor, oh my goodness, this step makes this step, makes this step, makes this step, and you believe the number of students who are now doing that. They weren't doing it at first. Finally, you started writing notes on your test when I return your test or quizzes. Organize your work. Some students are working up here, working here, maybe they write me a note, flip to the back, and I'll flip to the back, and I'll put it on the back, and all of a sudden I see another note on the back, it's on the scratch paper, Professor, I passed out to you. Oh, you did? Yeah, it's on the scratch paper. Whoa. Which works, but I understand, absolutely, I had to have scratch paper when I did my math. But guys, I'm trying to get everything organized for you. Not just for the sake of me, but when you move on to the next instructor, some instructors will not even score your tests. It's all messed up. In fact, one student told me at the beginning of class, when the course first started, he said his instructor drew not a straight line. They took the point off. Remember that strict, if your line, they ask you to draw a line, and the line's not